Hey guys, this is video 15.6. We're going to be talking about functional groups. Big thing you want to remember with dealing with these functional groups is table R. Okay, don't try to memorize all this. I'm going to kind of go through at a faster pace than normal, just kind of giving you guys some ideas and exposing you to functional groups and kind of what they are and what you should be looking for. But the reason I'm going to go faster is because you have table R in your reference table that shows all the different classes of compounds. They show what the functional group looks like. They show you a general formula, and then they give you an example of each. So sometimes they might even ask you to give one that's actually on your reference table. So know where to look. Don't try to memorize it. A lot of the naming still holds true from what we've already learned with the alkanes, alkenes, and alkynes. Pretty much everything you're going to see with functional group, guys, is an alkyne. No, I'm sorry, excuse me, an alkane. And then has a functional group kind of attached to alkane series. So keep that in mind as we go along. One thing I want to point out, guys, R just means the rest of the hydrocarbon. Okay, rest of the hydrocarbon, so that's kind of the chain that would be attached to it. Notice some have like 2 chains, so that's where you get the R prime. Or even 3 down here with the amines, where they could have 3 bonds. The big thing you want to remember, guys, how many bonds can carbon have? All right, carbon, only 4 bonds, and it has to have 4 bonds. So if it has less than 4, you've done it wrong. If it has more than 4, you've done it wrong. Nitrogen can only have 3 bonds. Okay, so 3 things attached to it, whether it's, attached to a carbon chain with 2 H's or 1 H or no H's with it coming off. So just keep that in mind as we go throughout. All right, our first functional group we're going to talk about are the halides, or the halocarbons. It's just one or more hydrogen atoms, guys, that's been replaced by a halogen. Okay, it's been replaced by a halogen. Same rules as naming our hydrocarbon branches, except now we've got to state where the halogen is. So just like we've done branch naming already, same thing, lowest number location of the carbon. So 2-chloropropane. Start with your long chain first. So propane, all right, so C, and then 2-chloro, we put a chlorine there, and then fill in our hydrogens, making sure that every carbon has 4 bonds. All right, same thing here. Let's take a look. Here's my chain. Longest chain is going to be 3, so that would be propane. Notice how now it would be 2-fluoro, 2-methyl, and I'm going to run out of space here, so excuse me for kind of going off at an angle. 2-fluoro, 2-methyl propane. It could potentially also see this one, guys, as 2,2 fluoromethyl propane. Don't get hung up on that either way. Just know that, hey, there's a methyl group coming off carbon 2 and there's a fluorine coming off of carbon number 2. But notice again, with these examples so far, it's the same as what we've already done. You guys pause the video and try this last one, 2,2,3-trichlorobutane. So butane, start there. 4 carbons. Trichloro means you're going to have 3 chlorines hanging off. So I've got 1 at 2, I've got a second one at 2, and I've got 1 at 3. And I'm going to put my CLs for chlorine. Then I'm filling everything else in to make sure that every carbon has 4 bonds, and that's what we would look like. Okay? So pretty straightforward for the halocarbons. Group 2, alcohols, very similar, except now instead of being replaced by a halogen, they're being replaced by a hydroxyl group. All right, and OH is going to be hanging off. And instead of E for the ending, it's all, OL. Same rules as before. Alcohols, guys, are not bases. All right, they are non-electrolytes. They are polar and they are water soluble. Notice here, and we're going to talk about this later on in these 2 videos, that they look similar to organic acids, but organic acids are more complex. So again, when in doubt, you're going to go back and look at table R. Look how the organic acid compares to an alcohol. An alcohol only has an OH. Organic acid has that whole piece hanging off that we'll talk about later on. So, same idea, propanol. Notice this one is actually in table R, but don't worry about it. I mean, you can go back and look, but if they don't give you that one, start with your long chain. Prop, so I've got 3 carbons, and then it's 1 is where the hydroxyl group, the OH, is going to hang off of. So I could either put it at this end I could put it like this. I could put it down here. Guys, it doesn't matter as long as it's on one of the end carbons. I could have also put it over here on this side over here to the left. So try to name this one. All right, pause the video and try to name this. So find your long chain first. 1, 2, 3, 4. So I've got bute, and I've got this OH group hanging off. So it's butanol. And then the last step is I've just got to mark what carbon that OH group is hanging off of. So that would be carbon 1, 2. So this is 2-butanol. Okay? So again, table R has examples. Follow it. Don't try to memorize it. The other piece you want to make sure you note with alcohols, guys, are primary, secondary, and tertiary. Primary means 1 carbon. Secondary means 2 carbons. And tertiary, as you probably guessed it, is 3 carbons. And it doesn't look neat, but that's okay. Guys, what I mean by the carbons is that the OH is located on a terminal carbon, meaning that the carbon it's attached to is attached to one other carbon. So here's pentanol. So start with your 5 for your pents. All right, and then the OH is going to hang off of one of the ends. So if I highlight this and show this to you, here's my alcohol group, right? It's got to have that carbon. It's attached to one carbon. And then take a look. This carbon right here is only attached to one other carbon. The other things surrounding this carbon that the OH group is attached to are just hydrogens. That's how we know it's a primary alcohol, meaning one carbon. Let's take a look at our secondary alcohol. Okay. Let me start with my highlighter, actually. This is going to be a secondary, because here's my alcohol group, right? OH is attached to one carbon, and then the carbon it's attached to, here's a carbon, and there's a carbon. So if we were to draw this structure out completely, instead of the line structure, 1, 2, 3, 4, 5, there'd be 6 carbons in it. All right, and then the OH is hanging off the second one, and notice how, there's a carbon, and there's the 2 carbons, and this would just be an H right there. So let's name it. Long chain is going to be 6 carbon long, so it's going to be hexanol, because we've got that OH group hanging off, and then where is that OH group hanging off of? It's carbon 2, 2-hexanol. Okay, and then likewise with a tertiary. Okay, we've got 2-methyl 2-propanol. Start again with your long chain. So I've got 3 carbons, and I know that my all group is on carbon number 2, so here's the OH, and then it's 2-methyl. So I've got 1, 2, here's a methyl group hanging off, and I'm going to fill in with my hydrogens. So again, if we take a look at the picture of why this is a tertiary, okay, there's my alcohol group, and then how many carbons are attached to that carbon? 1, 2, 3. That's where I get those 3. Okay. Now, dihydroxy. Dihydroxy meaning diol. It's got 2 OH groups. So ethane, diol means 2 all groups, 2 OH hanging off just like that. We could also have a trihydroxy alcohol. Don't overthink it, guys. Use the tools you've already learned. Tri means 3. Hydroxy is the alcohol, the OH. Okay, OH means hydroxy, like, hydroxide, something you guys have used all throughout the year. Propane triol, 1, 2, 3. That's my propane. I've got OHs hanging off of each carbon. And then fill in my hydrogens. Okay, so use the tools we've already used. Don't overthink it, guys. Use the pieces of the name that you are familiar with to help you come up with the structure. Group number 4, ethers. Ethers. They kind of have a bridging hydrocarbon chain. Name the 2 branches off the O, alphabetical if necessary. It doesn't matter which side you start with. The only thing that matters, guys, is that if they're the same branch, we use di, name the branch, and then ether at the end. Never use numbers, okay? Since there's only 2 sides, you don't have to number them. It doesn't matter which side is which. So here, I've got methyl ethyl ether. So ether's my clue that I'm starting in the middle with an oxygen. And then I've got 2 branches coming off of that oxygen. Doesn't matter, I can put the methyl group on the left, I could also put the methyl group on the right. Just as long as one side has methyl, one side has ethyl, alphabetical can be the way, it really doesn't matter, okay? Just make sure you have both sides the same. Now, one way that might help you remember the difference between an ether and something later we're going to talk about esters. My chemistry teacher said it this way. To this day, I still remember it. The ether bunny. So if you take a look, guys, you've got this O in the middle, right? So it's kind of like there's two bunny ears coming off of it. If that's an easy way to help you remember, great. If not, table R. Okay, look at table R. So here, I know ether is going to be my ending point because I've got an an O in the middle. Now I'm going to look at both chains. Well, this is 2, so that's an ethyl. Well, this is also 2. So they're both ethyl branches. This is where I would call it diethyl. Okay, diethyl ether. You guys pause the video and try to draw butyl propyl ether on your own. All right, so ether, starting here. Again, doesn't matter which side you put them in. I'm going to put propyl on this side. So 3 carbons. And then I'm going to put 4 carbons over here. You could have had it the other way. Again, it doesn't matter because they're both the same structure. They're just flipped. Okay? So that's an ether. Number 4, aldehydes. Now, this is one new piece here, new term, a carbonyl group. Guys, a carbonyl has got a C double bond O. We're going to see this in a few different ones. What I would encourage you guys to do is on your personal reference table, table R, write what a carbonyl is. All right, so as you're studying, you can kind of drive that home. Carbonyl equals C double bond O. All right, that's something big you need to know right away. It's found on a terminal or end hydrocarbon. So terminal. Aldehydes, guys, be very careful. They're similar to ketones. Ketones are going to be the next thing we talk about in the next video, so we'll talk more about how they differ. The big difference is where they are. They both have a double bond O, but an aldehyde is on the end carbonyl. It's terminal. Ketones are on internal carbons, which, again, we'll talk more about. So remember, it's an end carbon here with an aldehyde. But same thing, propanol. That ending AL is your clue that, hey, there's an aldehyde. Prop means 3. If they gave you propanol to draw, go to your reference table because it's the example that they give you. So I've got propanol, then my carbonyl group has to come off the end carbon. It could have been there or it could have been over here. Same thing. All right, same thing. And then fill in, make sure every carbon has 4 bonds with hydrogens. Now, this guy, be careful. It's very easy to start putting it like that. But guys, how many bonds does it already have? He's got 1 here, 1, 2, and 3. Only 1 other hydrogen would be hanging off here. And if you look on table R, that's what it shows you. This is your aldehyde group here on the end. Okay? You guys pause the video and try to name this guy. So if this was a multiple choice problem or if this was a short answer one, guys, this is your clue. There's the functional group in your compound. So I would go to table R. Oh, that's an aldehyde. So I'm going to start by naming my long chain. 1, 2, 3, 4, 5. 5 means pent. And I'm going to look on table R. Oh, well, the example they gave me was propanol. Well, prop means it has 3, but this case I had 5 carbons, so this is going to be pentanal. Pentanal. All right. So I'm going to pause this video here. You guys are going to pick up in video part 2 with the rest of the functional groups.